In this video, we're going to use the quotient, reciprocal, and Pythagorean identities to find the values of the remaining 5 trig functions. And it says round your answers to 4 decimal places. They have given me the cosine of t and what that equals to. They want me to use these identities that I've listed here to find the remaining 5 trig functions, which are sine, tangent, secant, cosecant, cotangent. Those 5 I have to find and find their value just with this piece of information that they've given me and the use of these identities. And notice that they've given me the cosine of t. T, remember, is an angle. And when it doesn't have a number in the angle spot, it means any angle. But they do make this warning here, if you can call this a warning. It tells you where t is located on the coordinate plane. So let me just make a little drawing here to the side and locate where this angle t is. It says t has to be less than pi halves but greater than 0. Here is 0 and here is pi halves. So that means t is somewhere in between 0 and pi halves. That means t is in the first quadrant. Somewhere in here is t. Why is this important? Because if I'm in the first quadrant, then that means that all of my trig functions that I find in this first quadrant are positive. Okay? Now, where is this cosine of t equal to this value other than the first quadrant? Well, cosine of t, remember cosine is your x coordinate. Where is cosine positive? That only occurs in your first quadrant and in your fourth quadrant right here. Now, that's why they have to tell you where t is, because if you don't know where it is, when you go ahead and find sine of t for this same angle, if I'm in the first quadrant, sine of t would be positive, but if I'm in the fourth quadrant here, my sine of t would have to be negative. So that's why they have to tell me where I'm standing. So I know I'm in the first quadrant. That is going to influence the positive or negative sign that I place on my trig functions, okay? So let's go ahead and use these identities to find the other functions. They gave me cosine. Now, what can I do with cosine? If I wanted to find tangent, look over here in your quotient identities. If I wanted to find tangent, I would need to know sine and also cosine. I know what cosine is, but I don't know what sine is. So right now, I can't find tangent, okay? Because that would be 2 unknown values in an equation, and that's impossible to solve. Cotangent, same thing. I can't use it because I don't have enough information to solve for cotangent. I would need sine, okay? For my reciprocal identities, having cosine, I can find secant very quickly, right? Because I know that secant is 1 over cosine. So this is very quick to find, secant. I can also use the Pythagorean identity, cosine squared t plus sine squared t equal to 1 to find the sine. So here I have found 2 identities that I can use right away. One with this one I can find secant, and with this one I can find sine. So I'm going to find secant first just because, okay? So let's go ahead and move this down a little bit. And let's find secant. Secant of t is equal to 1 over cosine of t. And since I know what cosine is, secant of t is equal to 1 over 0.4167. And that will give you secant of t is equal to 2.3998 8. Now remember they said round your answer off to 4 decimal places. So I found secant. Okay? Now let's go ahead and find, I'm going to use another color. Let's find the sine using this identity. I know cosine squared of t plus sine squared of t equal 1. I know what cosine is. I want to find sine. So I'm going to plug in the value for cosine squared. That would be 0.4167 squared plus sine squared of t equals 1. Now solving for sine, that would mean subtracting this value from each side. Let me solve this first. 0.4167 squared. Let me just solve for it. I didn't write down what this value is in my paper, and I don't have a calculator now, so I'm just going to subtract on both sides 0.4167 squared. And on this side also, subtract 0.467 squared. And what I get is, this cancels out and I get sine squared of t is equal to 1 minus 0.4167 squared. Let me scroll down, and sine squared of t is equal to 0.8264. And since I have sine squared but I want the sine, I would have to square root both sides. And when we do square root, we get a plus and a minus, right? But keep in mind that this angle t that we're dealing with is in the first quadrant. So that means that the sine in the first quadrant is positive. The sine function is positive. So I'm going to choose the positive here. Sine of t is equal to 0.9090. Okay? Now we found sine. So far we have secant and we have sine. Now that I have, it's very easy now to find all the other values. I'm going to scroll up here. I have cosine, I have sine, and I have secant. Now notice tangent is sine over cosine. These two values I have, so I can find these two very easily. Let's do tangent of t is equal to sine of t over cosine of t. That means that the tangent of t is equal to 0.9090 from the value we just found for sine over 0.4167. That's the value that was given. So the tangent of t is equal to 2.1815. We found tangent. If I have tangent, it's very simple to find the cotangent, because cotangent is 1 over tangent, right? Cotangent of t is equal to 1 over tangent of t, and that equals 1 over 2.1815. So the cotangent of t is equal to 0.4584. Now there's another way to find cotangent of t, which is cotangent of t is equal to cosine of t, which we have, over the sine of t. Okay? And you should get the same answer. You can try it and check if you get the same answer. It should be equal. Okay? We have cotangent, tangent, cosine, sine, and secant. We're missing cosecant. So let's do cosecant here. Cosecant of t is equal to 1 over sine of t. the cosecant of t is equal to 1 over sine, which is 0.9090. Cosecant of t is equal to 1.1001. And you're done. You found all the remaining 5 trig functions using the identities. I hope this example helps. You should go back and try it on your own and see if you get the same numbers and check, okay? I will do another video on another example, okay? I will see you then.